Thank you, Dr. Barrett. And so when people think about chemistry, they think about those colorful tubes. And those colors seem to represent new drugs, new materials. But what else in the tubes? The answer is a lot of solvent. And most of our daily chemicals has been synthesized by solution-based chemistry. And solvents are used to dissolve reagents and products. And in our daily life, the most common and clean solvent is water. Water is a solvent for the biochemical reactions in our human body. But in industry, the strong acid and strong base solutions are commonly used, and so does the organic solvents such as alcohols, ketones, and alkanes. And those solvents are corrosive and toxic. Organic solvents are synthetic chemicals themselves, and people synthesize organic solvent from food or oil. And lots of energy has been consumed during the production and usage of the solvent. However, people believe without solvent, the reaction cannot happen or happen extremely slowly. They think it is the only way to make chemicals. In pharmaceutical industry, 80% to 90% of the mass of a pharmaceutical operation equals to the mass of the solvent, and the solvent will determine the toxicity of the pharmaceutical process. In metallurgical industry, the corrosive solution will increase the risk of the management. And in Hungary 2010, the leaking of the sodium hydroxide solution killed 7 people and more than 100 people get injured. And how do people make new materials? People will start from the minerals such as metal oxide, metal sulfides. They use very high temperature to get pure metals, and then they use strong acid, strong base to get metal salts. And then they get new materials. But is this process really necessary? And there will be a lot of energy and solvent consumed in this process. And how does nature make new materials? Nature will start from the rock directly to the materials. This method has been called mineral weathering process. And for example, the lichens on the rock will produce oxalic acid, and it will convert the inert minerals directly to the metal oxalate materials. So this process is very low energy and solvent free, but it's going to take a couple of years. We need to accelerate it. In our research, we use a closed glass box. We put the water in the bottom and put our mixed reagent on the top, and this solid state reaction only accelerated by the water vapor. And after 1 to 10 days, the reaction can be totally finished at room temperature of 45 degrees. We have successfully converted those metal oxides to those colorful metal oxalate materials. If we use organic molecules as templates, we can get even more complicated structures. And the commercial pipe bismuth and these advanced materials for the carbon dioxide storage can be also synthesized by this process. We also applied our method to the mineral separation industry, and since our method is very easily to be scaled up, we are currently applying a patent through McGill University. And I hope my industry can make our my research can make our industry more cleaner and better. Thank you.